Good morning. Today we'll be understanding the congruency of triangles. Congruency of triangles. Let's draw a triangle and let's name it A, B, C. Now, if we have another triangle, let me call it D, E, F. I may say that these two triangles are congruent only when they can completely represent each other or one can be overlapped on the other. For example, if angle A is equal to angle D and angle B is equal to angle E and angle C is equal to angle F and AB equal to DE and BC equal to EF and AC equal to DF. In this case, I can simply say that ABC and DEF are completely equal in all aspects. Now, to understand this, there is an abbreviated term called CPCTC. This means the corresponding parts of congruent triangles are also congruent. How do you understand this? C. Congruent, corresponding parts of congruent triangles are congruent. Now let's observe these two triangles. What are the corresponding parts here? You can see that there are three vertices in a triangle: A, B, C of triangle 1 and D, E, F of triangle 2. Now this vertex A and vertex D are corresponding vertices, vertex B and vertex E are corresponding vertices, and vertex C and vertex F are corresponding vertices. Similarly, side AB and side DE are corresponding sides, side BC and side EF are corresponding sides, and side AC and side DF are corresponding sides. In the same way, we can also say that all the three angles are corresponding: angle A equal to angle D, angle B equal to angle E, and angle C equal to angle F. Angle C equal to angle F. So this is the meaning of this term CPCTC. Now let's talk about the conditions. The conditions. The conditions for congruency. Conditions for congruency. What are the conditions for congruency? Let me take another triangle A and now the first condition is SAS. It means side included angle and again side. Now if we take this side, AC is equal to DF and AB equal to DE. What is the angle included between these two? AB and AC includes an angle A, so I call this SAS. So similarly, angle D is included between DE and DF. So I can say that these two triangles are congruent by SAS. This means two sides and the included angle formed by these two sides, the angle which is subtended when these two sides are meeting. The second rule is ASA. This is very similar to this case where here we talked about the angle which is included by two sides, and here we are going to talk about the side within these two angles. For example, this is one angle, this is second angle, this is angle 2, this is angle 1, this is angle 2, and this is the side. Let me call this A, B and C, and another triangle D, E and F. So when you see this, angle A corresponds to angle D, angle B corresponds to angle E, and the side AB corresponds to side D. So we can say that these two triangles are congruent by the rule ASA. Angle, the side sandwiched between these two angles, and the angle, side, angle. Now let's come to the third rule. Third rule, which is AAS. AAS. This may be slightly confusing when you see what is the difference between talking about ASA, AAS, SAS. What it means is when you take two triangles A, B, C and D, E, F. Now let's take these two angles. Let's assume that A and D are corresponding and B and E are corresponding. Now where is this side? This side must be either opposite to this B. If you take this side as S1, then which side do you take here? You should take the same side which is opposite to the angle which you have considered. For example, if S1 is AC, which is opposite to angle B, here we should take the same S1 is DF. This means the two angles are equal and the side opposite to the equal angle should be considered. For example, if we consider this as S1, then this is wrong because this is opposite to angle D, whereas here this is opposite to angle B. So this shows a subtle difference between when you take AAS rule, we cannot take the wrong side. If we have taken side S1 which is opposite to angle B, first we have to choose which is the corresponding angle for B and then finalize on the side. Now this is the difference between SAS and the second one ASA and the third AAS. And the fourth rule is SSS. It's very simple. As the name suggests, when you take two triangles, A, B, C and D, E, F, side AB corresponds to side DE, side BC corresponds to side EF, and side AC corresponds to side DF. So these two triangles have all the three sides matching with all the three sides of each other, so they can be congruent by the rule SSS. Now the final rule, the last, is RHS. The word R says it's a right angle triangle, so we need to consider two right angle triangles. Let's take the two triangles A, B, C and D, E and F, where angle B equal to angle E, angle B equal to angle E equal to 90 degrees. Then angle A side AB equal to side DE and side AC equal to side DF. This means if in two right angle triangles, if the hypotenuse and any one side are equal to the hypotenuse and the other side, then these two triangles are congruent. The same rule applies here. If I take the hypotenuse here and this side, I need to take in a similar way the hypotenuse here and this side. So we can say that triangle ABC and DEF are both right angle triangles and they are congruent by RHS rule. Today we have discussed about all the rules by which the triangles can be called congruent. One more important thing is, the last and important is, when you are representing the two congruent triangles, suppose let me take this triangle and this triangle, I call this A, I call this B, I call this C, I call this D, I call this E, I call this F. Suppose let's say in this we know that by CP, the rule which we had studied initially was the corresponding parts of the congruent triangles, that is C, P, C, T, C. Now let's say this is angle A and this corresponds to angle E, and this is angle B and this corresponds to angle D, and this is angle C and this corresponds to angle F. Till now we have been looking at cases where A was corresponding to D, B was corresponding to E, and C was corresponding to F. Now if these two triangles are congruent, then we need to represent these triangles by not, if we write it as triangle ABC congruent to triangle DEF, this is wrong. Why? Because A does not correspond to D here, and B does not correspond to E here, and C does not correspond to F here. So we need to write, when we represent A, B, C corresponds to triangle A corresponds to E, so triangle E, B corresponds to D, D and C corresponds to F, E, D, F. When you see this, you can very clearly see that A matches with E, B matches with D and C matches with F. So when we represent like this, we can clearly say that the corresponding parts, that is A equal to angle E and angle B equal to angle D and angle C equal to angle F. Similarly, when you take the sides, you can say that AB equal to ED. Just match these pairs, and AC equal to EF and BC equal to DF. So today we have discussed all the rules by which two triangles can be called congruent, and in the next session we'll be doing some problems to prove that given two triangles are congruent. Thank you.